Okay, so here we go with section 3.3, which normally this is the one where everyone's a little excited about once we jump into it because it's just algebra. There's not a single thing in this section you haven't done before that you didn't do in Algebra 1. So we'll do a lot of examples, talk through a lot of stuff, but really this should be a nice kind of easy, laid back section compared to what we've had. However, I will say this, the plan for class is that when you come in tomorrow, I'm going to give you a bunch of problems to do, and then you'll work on them all hour long, and I'll individually walk around to help you out and see how things are going. So you have to pay close attention because there's very little room for you to say, I don't know how to do this. You've done all this before. It's just re-summarizing some things and kind of reintroducing you to it. So it says slopes of lines. We've talked about parallel lines. Now we're going to talk about slope and how to identify parallel and perpendicular lines through slope. So the first thing you have to remember is the slope formula. Slope as a definition. Okay, the definition of slope is the ratio of rise to run. Okay, so you've got your rise vertical change here, you've got your run here. And since y is the up and down movement of a point and x is the left and right, which is what run is, slope is the change in y, which is the change in movement vertically, over the change in x, which is the change in horizontal movement. So rise over run. And another thing that's important to recognize is that it doesn't matter really which way you do slope. It isn't really that important. The key is simply this. If this is y2, this is x2. Hopefully it comes out. So when you do y2 minus y1, you have to do x2 minus x1 on bottom. So whatever y value you use first, that's on top, the x value has to be the first one on bottom. So actually you can have for slope, you could have y1 minus y2. You would just have to put x1 minus x2 on bottom. So it doesn't matter which way you go about it. Okay. Now the first problem that we have is to find the slope of this line here. So slope of this line. Okay. Let's cut to the, I've got a drawing of it over here. There are actually two ways you can find slope. One is to use the slope formula. So this point here, S, is at negative 3, 1, 2, 3, 4, 5, 7. This point here at T is labeled at point negative 1, negative 1. Okay. So you can do slope, which is y2 minus y1 over x2 minus x1. So 7 minus negative 1 over, since I did 7 first on top, I have to do negative 3 first on bottom, negative 3 minus negative 1. Which gives us then 8 on top, negative 2 plus, or negative 3 plus 1 is negative 2. That gives us negative 4. Negative 4 over 1 actually is a fraction, which means to get from S to T, I'm moving at a ratio of down 4 over 1, down 4 over 1. Because again, this is the rise, this is the run. Okay. I could also think of this as moving up 4, left 1. So up 4, left 1. Up 4, left 1. That's another way we could look at it. Now I said there are two ways you could find slope. The other way you could find slope is if you're visually finding slope. And how you do that is you take a point, for instance S that's been labeled, and you just basically just move down until you're at the same level, in this case, as the other point. If you're starting over here, you go up. So I went down 7 units, which means on top it would be, so I didn't go down 7, I went down 1, 2, 3, 4, 5, 6, 7, 8. And since it's down, it's negative 8. And then I'm going to go from here right 2 to get to T. So negative 8 over 2. I'm going to simplify that. Whoops. Negative 4. So you can either do it visually, or you could do it using the slope formula like I did here. Okay. All right, another problem that you got there on your sheet, find the slope of the next line. Okay, slope of the next line. This one I like because it gets to some of the stuff we're going to talk about in the next one. So when you look at this, my point is P here, my point is Q there. P is at 0, 4, Q is at 0, negative 3. So to find the slope, again, y2 minus y1 over x2 minus x1, we do y minus y, 4 minus negative 3, over x minus x, which is 0 minus 0. That gets us 7 over 0. Oh, I hopefully remember from Algebra 1 that you can't divide by 0. That's undefined. Okay, so yeah, it's undefined. So that's our slope for the line there. Now the thing is, you could just say, and if I went from P to Q, I went down 7 over 0, or up 7 over 0. So oh, that's undefined. There's nothing going on there. So another way we could do is visually. Now the reason I bring that up is that there are 4 kinds of slopes that you should remember from Algebra 1. Positive, negative, 0, and this last one we just talked about, which is undefined. So looking at our slopes then, positive slope. Positive doesn't mean good or bad. Positive just means you have a positive value for slope. Okay, so if I go back to the, so I haven't looked at an example like this, but if I just kind of make an arbitrary point, we'll call it point 1 and point 2, to get from 1 to 2 I have to go up and rise, right and run. Well, that's a positive rise over a positive run, which will be positive. Or I could go from 2 to 1, down and rise, left and run. Well, that's a negative rise over a negative run, which is a positive slope as well. Now we got a negative slope already once. We did an example. This problem here. This guy gave us negative 4 for the slope. Why? Because it was decreasing. Oh, and I'm sorry, I forgot to mention that. When you read slope, you read it from left to right like you read a book. From here, from left to right, I increased in value. That's also why it's positive. Now I'm from left to right decreasing, so that's also why it's negative. Now, when I do that though, if I make up 2 arbitrary points on there, here and here, okay, I could go down first and then right. This would be negative, this would be positive. So we'd have a negative rise. This is going to take a second. Negative rise over positive run, which ends up being negative. Or we could have positive rise, which is going up, over a negative run, which is going to the left. So positive rise, negative run. Which a positive over, I'm sorry, I'm off the screen, all right. Which a positive over a negative is negative. So it's negative for both. Okay. Now, zero slope. Zero slope is whenever you have no rise. You're not rising. So you have 0 over the run, which is 0, because 0 as a fraction is 0 over any number. So horizontal lines, which by the way, horizontal is spelled H-O-R-I-Z-A-N-T, sorry, Z-O-N-T-A-L. I can't spell horizontal. Let's try that again. Horizontal. Yeah, I can't spell. H-O-R-I-Z-O-N-T-A-L, not T-L-E. It's what a lot of you guys want to spell it as. And then vertical lines are no run. You're just going up and down, so no run. So you have rise over 0 run. Well, that's undefined because a number over 0 is undefined. Okay. I also like to think of this as 0 effort slope. You're just walking horizontally with no effort whatsoever. It's what flat ground is easy to walk on. And then undefined slope is impossible slope. You're walking vertically up or down. It's impossible to do that unless you were Spider-Man. Okay. All right, so I suggest at this point in the video, you take a nice, like, I don't know, minute break or 2 or something like that. Pause it, stretch, get up. We're about 10 minutes. We still have a few things to go over before we're done. Sorry this one's so long, but there's no homework to be done, and again, this is all review, so hopefully it's nice and easy to do. So just take a second to yourself, pause me, go get a drink, whatever it is. All right, okay, so here we go, second part. Hopefully you took a break. If not, we're ready to power through. Anyway, recreation. So here's another application of slope. And this really is getting to actually what calculus basically is. Because if you ever take a class in calculus class, slope is basically what calculus is. So anyway, in 2000, the annual sales for one manufacturer of camping equipment was $48.9 million. In 2005, the annual sales were $85.9 million. If sales increase at the same rate, what will the total sales be in 2015? Well, in order to figure that out, we have to figure out what's going on to our sales. So we have to figure out what the rate of sales is. Well, if we think of this as an ordered pair, in the year 2000, we got 48.9 million. In the year 2005, we had 85.9 million. The question is, what is 2015 going to be? Well, what would be nice to know is, how much is this growing every year? So we can do that by finding slope. So y minus y, 85.9 minus 48.9 over 2005 minus 2000. Okay. Now on the bottom that's 5. Just to get the arithmetic right, because it's kind of late when I'm doing this, and I tend to be a little off of my arithmetic then. 85.9 minus 48.9 is 37. Okay, so 37 divided by 5 means $7.4 million per year is our increase. So writing $7.4 million every year to our recreation sales equipment, or equipment sales. Great. Now here's the deal. I want to know how much I'm going to have from 2005 to 2010. Well, or 2015. Well, that's 10 years. So this increase per year, 7.4 per year, I'm going to multiply it by 10. And that'll give me how much I'll have in 10 years that I'm increasing, which is $74 million. So now to figure out how much I'm going to have in 2015, I'll figure out, oh, how much did I have in 2005? Well, that was 85.9. I'll add 74, which is what I expect to be the increase, 9, 9, 15. So $159.9 million. Okay. That's insane. So I think it's just a made-up problem because that's way too much growth for one company over that much time. But who knows? Maybe they do. Okay. Next thing, again, something else you've talked about, perpendicular and parallel lines. Okay, and specifically to do with those slopes of parallel and perpendicular lines. Now, slopes of parallel lines, okay, two non-vertical lines have the same slope if and only if they are parallel. Okay, that's key here. Same slope tells you if you're parallel, unless you're vertical, because all vertical lines are also parallel. Okay. So this should hopefully kind of make sense if you think about what's going on with two parallel lines. As this line goes up, like let's say it looks like it's going up 3 over 1. If they're going to stay parallel, this kind of has to do the same thing, where it goes up in the same movement, up 3 over 1. Okay. The reason that we talk about all vertical lines being perpendicular, their slopes are undefined if you're vertical, so you don't have a slope. Okay. So, oh, I'm sorry, this line is actually a slope of 4, they told us. Whoops, I wasn't paying attention to their drawing. This guy's a slope of 4, actually going up 4 over 1. So it's not 3, it's 4 over 1. Okay, so same slope, but again, same idea. They have to go up the same amount and go over the same amount, because if they start changing that ratio, they're not going to intersect. Okay. Now, the other one that's a little trickier is perpendicular slope. Okay, perpendicular slope is not the same. What it is, okay, they define it as two lines, non-vertical lines. Again, we're talking about vertical and horizontal in a second, but two non-vertical lines are perpendicular if and only if the product of their slopes is -1. Okay, product of the slopes is -1. Now, if you're vertical and horizontal, it's like a vertical line to a horizontal line, it's always perpendicular. Now, the way you may remember it is not that their products are -1, although that describes it perfectly. 4 times -1/4, because this line's -1/4. When I do that, the 4's cancel, the negative stays, we get -1 for a product. The way you may remember it is that the slopes are opposite reciprocals. That's what you might remember, which 4 over 1, its reciprocal is 1/4, and then tack a negative on it. Or if you had like negative 3/7, its reciprocal is 7/3. That's negative, but then change the sign of that. It's positive 7/3. So that may be what you remember from Algebra 1 is that opposite reciprocal slopes are perpendicular. Okay. All right then. So let's see. Next example to take a look at, and the problem is this. We've got A, B, and C, D. We have to look at those slopes and determine if they are parallel, perpendicular, or neither. So here we go. First thing I need to do is find the slope of AB. I'm not even going to graph it. Forget graphing it. Just find its slope. So it's y minus y, so 5 minus negative 1, x minus x, 4 minus negative 2. That becomes then 6 over 6, which is 1. Okay, so now find the slope of CD. Y minus y, negative 2 minus 1, over x minus x, which is 9 minus 6. So again, negative 2 minus 1, 9 minus 6. Now that gives me negative 3 over 3, which is negative 1. Now you might not catch anything about that because of the fact that it doesn't jump out at you what's happening with their slopes. But these lines are definitely, first of all, not parallel, because parallel would be the same. And these guys are opposites. Okay, so it can't be parallel. Okay, so what could it be then? Well, opposite reciprocals would maybe work, but 1 and 1, those aren't fractions. However, I could write 1 over 1 as a fraction, and this could be then negative 1 over 1. So if I flip 1 over 1, what do I get? 1 over 1. And if I take the opposite of 1 over 1, I get negative 1 over 1. Oh, these guys are actually perpendicular. Plus, they pass the test of the definition of it as negative 1 times 1 has a product of negative 1. So they pass this part of that definition. The slopes products are negative 1, which is what they are here. Okay. Now, last example is a drawing thing. So hopefully this, I've already done that. I want to graph the line that contains the points Q, 5, 1, and is parallel to MN if it has a slope, if its M is at negative 2, 4, N is at 2, 1. So first of all, point Q is at 5, 1. So I'll plot 5, 1. So 1, 2, 3, 4, 5, 1. So there's point Q at 5, 1. Hopefully that comes out on your screen. If not, just count it over 5 up 1. Now the second part is this. M is at negative 2, 4. N is at 2, 1. So here's the line that contains them. I want this line here to be parallel to that line. Well, in order for that to happen, it has to have the same slope. So let's find the slope of MN. Well, y minus y, so 1 minus 4, over x minus x, 2 minus negative 2. That gives us negative 3 over 4, which, that's it, that's our slope. So what that means is then, point Q has to have a slope of negative 3/4, which either means negative 3 over positive 4, or positive 3 over negative 4. So this will go down 3, right 4, or it'll go up 3, left 4. So from right here, go down 1, 2, 3, right 1, 2, 3, 4. Or from here, go up 3, up 1, 2, 3, left 1, 2, 3, 4. Yeah. And then, I don't know, let's see if I can grab something like nice to make kind of a ruler out of this. This will kind of work. It's not perfect, but it'll work well enough. Ah, dang it. And here's this line originally, which I didn't do the greatest job with drawing the first time. That's why this looks so not parallel. There you go. That's a little better. So when you freehand it, it doesn't jump out as being parallel. So use a ruler; it'll look prettier. But yeah, there we go. Or maybe If you go up the right, no, I did. Yeah, it just looks off. Okay, so there you go. -3 over +4. There's our slope. There's our parallel line that goes through it. Okay. Again, I apologize for being such a long video. Tomorrow in class, though, basically these problems just like these 6 or so we did, and then you'll work and we'll go over it at the end of the hour together. Okay, thanks.